uh, dynamics and the equals density, cross-section area, and the drift velocity. So this video is about this formula and where it is actually used in the past paper. Let's see to it. Let's say we have a pipe and pipe has a cross section area A and there is a and in liquid is coming out from the pipe with a force F, right? And the density of of this pipe is this rho, and the length where the same speed is observed from this point to this point is L, and the liquid and or the fluid travels from this to this point at time t. So let's this first F equals ma, right? And we switch this mass with density into volume, and the acceleration is rate of change of velocity. So volume is transformed into a cross section area into L, density cross section area L. If you just move this T to this, right? So it is L over T, and L over T is again velocity. So density times cross section area times velocity square. So we have this formula. So this we need to remember force, density, area, and speed square. Now check how we apply this formula to which under which conditions. Okay. So let's say we have this May June 2017 paper 1 2, and the question number is 9. Water flows out of a pipe and hits a wall, right? So this is having a constant velocity, right? And this is a pipe and this is a wall, right? When a jet of water hits the wall, it has an horizontal velocity v and cross-sectional area A. The density of water is rho. The water does not rebound from the wall. Okay, the water does not rebound from the ball, so there is no change in momentum. So we have to consider this as well. What is the force exerted on the wall by water, right? So the force exerted on the wall by water is calculated as force density times area and speed square. So if we want, so this is the straightforward question. So density, area, and the velocity, square of the velocity. This is option number D. So let's check another question, which is winter 2020, paper 1, variant 3. A device for spraying paint consists of a box with its axis horizontal and vertical. One of its vertical faces contains a small hole. Paint is fed into the box under pressure via a vertical tube and exits through the holes as a fine stream moving horizontally. So there is no curve; it is just moving in a same in a linear direction, right? So in a linear direction, there is a drift velocity, right? So we can apply this force, density, and the speed square of the distance, right? So the paint is ejected at a speed of 2.5 meter per second, ejected speed, through a 400 holes. Each of area is zero point 0.5 millimeter square. The density of the paint is 900 kilogram per meter cube. What is the horizontal force required to hold the device stationary as it ejects the paint? So the difficulty level a little bit harder means the force which the liquid is coming out from the this hole. So the same force must be applied in order to make this stationary. So whatever be the force is the force by which we can hole. It can be hole. So let's take it out. So area is zero point 0.4 millimeter square. So we need to convert into meter square. That is a zero point 0.4 into 10 power minus 6 meter square. And remember, it is from the 400 holes, right? So it the area it must be multiplied with the 400 holes. That means the cross section area of all holes will be here. And so the density is 900, and the 400 holes times zero point 0.4 into 10 power minus 6 will be the area. Okay, and this area times 2.5, which is what the speed, right? So we need to multiply it. So 2.5 square, this is your area, and this is the density. So the answer is zero point 0.9 Newton. So option B is the correct answer. So what is actually the catch in it? You need to convert first millimeter into meter square. Value, whatever you got the value, you should multiply with the number of holes, and you need to apply Newton's third law, that for the force which is from which the spray is coming out, you need to force apply exactly equal and opposite force. So these are the catches, and the option is B.